So we're in section 10.4 today. And we're talking about area and perimeter. With similar figures. So when we talked about similar figures a couple of chapters ago, what was our important technique? What was our main method of working with similar figures? Cross multiply. So we have fractions, and they're setting them equal to each other, and cross multiplying. So we're either talking about fractions or ratios, and when we set them equal to each other, we're talking about proportions. So that was exactly it. So with similar figures, we're talking about proportions. So today we're going to talk about areas of similar figures. So it's going to involve proportions as well. So that's going to be there's really one technique, one method we're going to use to solve these problems. Has to do with setting up a proportion. So what we're going to say is two similar figures. So with similar figures, and we're going to make a ratio of their sides. With sides, in the ratio A over B. So we're just making a fraction of their side lengths. Now before we go on, let's think about what we just talked about in last chapter, when we made a ratio of the side lengths when we were talking about dilations. What was the other word that we used for the ratio of the lengths when we did dilations? Do you remember? When we took the length on the bigger piece and divided by the length of the smaller piece when we did the dilation. What was it? Our scale factor. Perfect. So our sides are in a ratio of A over B, and the other way that we can say that is the scale factor. Those two are saying the same thing. We can say the side is in the ratio of A over B, or our scale factor is A over B. Have perimeters in the ratio A over B. So the ratio of the perimeters is the same as the ratio of the sides. And areas in the ratio A squared over B squared. So what this is telling us is that if our side ratio, so I'm just going to write it in a little shortcut here. Side ratio is A over B. Perimeter ratio A over B, and area ratio A squared over B squared. So on your graphic organizer, you have a little circle at the 9 o'clock position. And it says perimeters, add all the side lengths. What I would do is draw a little line out from that circle and write side ratio A over B. So write this out from the side of that circle. Side ratio A over B. And then inside the circle, you have a little box for perimeter ratio. You would write A over B there as well. And area ratio, you would write A squared over B squared. So make sure you write on there, out to the side ratio A over B, and inside the circle, under the little the little heading for perimeter ratio, right, A over B, and for area ratio, right, A squared over B squared. That's our important piece from today's section.
Wait, if all that's true, then what?
No, so if we have similar figures, this is true. The
If all
perimeter
that's
is
true.
right.
If all that's true, then.
No, we're starting out with similar figures. So the problem is going to tell us you have similar figures. So we know the figures are similar. If the figures are similar, the perimeter ratio is the same as the perimeter ratio is the same as the side ratio, and the area ratio is the square of the side ratio. Okay? Yeah, man.
Can you repeat where we write the side ratio?
I would put just a little line out from that circle, out from the circle at the 9 o'clock position. It says perimeter. We'll put a little line, perimeter ratio, or side ratio, A over B. Inside, you would, under the part that says perimeter ratio, write A over B. And where it says area ratio, you would write A squared over B squared. So this is really the only piece of information for this unit, or not for this unit, for this section. All we need to know is the side ratio. The side ratio tells us the perimeter ratio. The square of the side ratio tells us the area ratio. And we're going to write proportions with those ratios to solve problems. All right, everybody good with our ratios? Did we all get them on our graphic organizer? Okay, so let's look at a few problems. So these rectangles are similar. So let's draw a couple of rectangles here. So the problem tells us these are similar rectangles. So in this section, that's how we're going to start. And let's say this side is 8 millimeters and this side is 6 millimeters. We want to find the ratio of perimeters and the ratio of areas. And let's do our ratios small to large. So our key here is the ratio of the sides. So let's write our side ratio. What is the side ratio small to large? 6 over 8. Just take this side divided by that side. And I can reduce that to, what is that fraction reduced to? 3 over 4. Divide everything by 2. So my side ratio is 3 over 4. Well, that's my key. How do we find the perimeter ratio from the side ratio? What did we just write in our graphic organizer? The side ratio is A over B. The perimeter ratio is A over B. They're the same. Side ratio and perimeter ratio are the same. We don't have to do anything. And what do we do to the side ratio to get the area ratio? Square everything. So we get 3 squared over 4 squared, which is 9 over 16. And for this problem, that's all we have to do. It just asks us for these ratios. Side ratio, perimeter ratio, always the same. We don't have to do anything. Area ratio, we square it. We square the side ratio. That's all we have to do. Good with that example? All right, let's look at one where we can actually figure out the area from some ratios. So here we'll work with hexagons. Here's my hexagon. And we're going to say these are similar. And the fact that they're similar is what lets us set up these proportions. And we're going to say that this side is 7 feet and the bigger side is 10 feet. And the problem tells us the area of the smaller is 127.3 square feet. We want to find the area of the bigger. So just like in the last problem, our key is the side ratio. So since the problem asks us for the area of the bigger one, let's put the bigger one on top so our fractions are easier to work with when we set these ratios. So let's write our side ratio. So what is our side ratio, big to small? 10 to 7. The problem asks us about the area, so let's find our area ratio. So what do we do to the side ratio to get the area ratio? Square it. Area ratio is 10 squared over 7 squared. And 10 squared is 100. And 7 squared is 49. The problem also tells us the area of the smaller. So this area is 127.3 square feet. And it wants us to find this area. Let's call this area X. We like to call things X when that's what we're looking for. And let's use those two numbers to write an area ratio also. So the area ratio is also big to small, X over 127.3. So I use the side ratios to get an area ratio, and then I use the area that the problem gave me to write another area ratio. And those have to be equal. Those are both the area ratios. Well, how do I solve for X here now? We're almost home free. Cross multiply, and because we set this up so our X is on top, all I need to do is multiply both sides by 127.3. I'm going to multiply this by 127.3. Those cancel, and I get X equals, when I turn my equation around the other way, 100. This is what I'll plug into my calculator, 127.3, and I'm going to divide by 49. Plug that all into the calculator, and I get X equals, when I calculate this out, 259.8, and my units would be square feet. Now a couple of ways that you could check your work here. We did our side ratio big to small, so our area ratio needs to be big to small. So our bigger number has to be the one on top. We're finding the area of the bigger hexagon, so our answer probably should come out bigger. If your answer came out smaller than 127.3, that would tell you maybe you did something wrong. you might need to go back and check your work. So a couple ways we can check to make sure that we're setting things up right. All right. Everybody good with that example? So this idea, starting with the side ratio, writing the area ratio by squaring it, that's the key idea from this section. All right, let's do a problem where we go in reverse, where we have the area ratio and we want to figure out the side ratio. All right, for this problem, we have similar figures. With areas of 32 meters squared and 50 meters squared. We want to find the scale factor. Now thinking back to what we said right at the beginning, what's another description for the scale factor? What's another way of saying the scale factor? We talked about it right at the beginning. The ratio of the sides. The scale factor is the same as the ratio of the sides. So what this problem is asking us to do is find, so we're kind of translating here, find the ratio of sides. So we want the side ratio. So here we're working backwards. We're working in the opposite direction that we did the last couple of problems. So I'm going to write my area ratio. So what's going to be the area ratio? Let's make a fraction of the areas. So how do we want to write it? 32 over 50. And let's say that the side ratio, we'll use the same thing that we did at the very beginning. Our side ratio is A over B. We don't know what those numbers are. It's A over B. What do we do to the side ratio to get the area ratio? Square it. So the area ratio is A squared over B squared. The area ratio is also 32 over 50. Those are the same thing. So I can say this equals 32 over 50. I want to find A over B. I want to find the side ratio. How do I undo those squares? Square root. I have to take the square root of everything. I'm going to take the square root of that, square root of that, square root of that, square root of that. When I take those square roots, I get square root of A squared, I just get A. Square root of B squared, I get B. And the square root of 32 over the square root of 50. And we're not quite done. We want to simplify this a little bit. I'm going to rewrite the square root of 32. I'm going to write it in simple radical form. So I'm going to simplify these radicals. 32 is 16 times 2. And 50 is 25 times 2. So this equals the square root of 16 times the square root of 2, which is 4 square root 2. Square root of 25 times the square root of 2, which is 5 square root 2. Those cancel and I get 4/5. So my side ratio is 4/5. What if the problem asks us for the ratio of the perimeters? It's the same. Very nice. Ratio of the perimeters would be 4/5 also. So to go from the ratio of the areas to the ratio of the sides, you have to take the square root. So to go backwards, you take the square root. To get to the ratio of the areas, we square. To get from the ratio of the areas to the sides, we take the square root. And going in reverse. All right, we good with that example? Okay. That is our key idea. Find the ratio of the sides, square it, we get the ratio of the areas. We have the ratio of the areas, take the square root, we get the ratio of the sides. Ratio of the perimeters, same as the ratio of the sides. Okay. Homework. I'll write that up. We'll pass the folders out and go over the last homework. Page 638. There we go. Common Core